Okay, so I'm here to tell you more really about a startup that I co-founded and to commercialize some of the technology that we developed actually at Johns Hopkins. And let me just put it in presenter mode here, or presentation mode. And this is my first time I joined this community. I'm looking forward to doing more of this. Um, And so the kind of the problem as an engineer and as a researcher that I lived around for about 30 years. I've been in the world of AI, autonomy, and robotics, and we keep running into the same problems involved, with machine vision. You basically start out with sensors, and you take that data, dump it into a bunch of processors. Note that I said processors, didn't say Mac or Windows, so nobody gets offended here. And then you output what typically is called actionable information that drives a machine, and it could be really your AC systems, it could be your coffee machine, could be tractors if you're into farming, or drones, which is the space that I lived in. And but at the end of the day, really, that approach has been around for many years, and it has had key challenges along the way. And so, as an engineer, I really try to find a problem first, and I develop a solution for it, not the other way around. So the problems that we kept running into are starting with the sensors. So if you are playing a game of trying to catch that water drop, and you have two cameras to use, one on the left side that's faster than the camera on the right side, you can catch the water drop every time on the left side because you can see the water dropping. On the right side, it only shows up once because that camera runs at 30 frames per second. The camera on the left runs much faster. Okay, so that's one problem, is that the cameras that we have today typically are slower than they need to be for some applications. Now you have the opposite problem. Now you have cameras that generate a lot of data, but it's not very meaningful. So if you look at a typical camera that they install on intersections, on the left side, this is the amount of data, and we're talking about gigabytes per second being sent out to the cloud. On the right side, you can see the amount of data that's actually relevant. And if you're looking at the bandwidth on the top right corner, you can see the huge difference in the bandwidth. Okay, so we are overwhelming the system now with data that's not very useful. Now here's the one that's even more interesting. I don't know how many of you drive cars that have advanced ADAS systems, but trust me, they don't work very well. Okay? And the reason for that is between the time you take all the sensor information, you push it through your processors, name your favorite processor, it doesn't really matter, and try to get the information out of it, it's still kind of slow. It's actually slower than a human vision. Okay? And if you're interested in that, there's actually a nice AAA study that's out there available for you guys to see. Okay, so these are really significant problems, and the reason for that is both cameras and processors were really developed independent of each other. We ended up just starting to pull something off the shelf, putting it, and trying to make the best use of it. Okay, that's really what it comes down to. Cameras were designed to reproduce perfect images like we see. Processors were really, more into kind of get a stream of data and compute on it. Okay. And so you put them together and you have really a less than an optimal architecture that causes, some of the examples I showed you earlier. So, knowing this problem and working on it for many years, we came up with what we call the Oculi SPU. It's basically a single chip solution that combines the sensor and the processor on the same chip. Okay. And that really allows you to do things much faster because now the computer or the processing is right at the same node as the sensor. You can run it very fast and output the information that you need instead of simply outputting data. So that saves across the board and allows you to do some of the cool things that I'm about to show you. So, for example, our SPU chip is a single camera plus processor solution. You can deploy it to, as you can see in the video on the left side, you get a full frame, just like any camera would provide you, but we also program it to only output the edges of what's moving. And it allows you to output a lot less data, but still enough for you and I and hopefully for a smart algorithm to recognize, look, there's a lady walking her dog. And that's, if you're looking at the data, that's a very little data being outputted. We can even output a less data if you want, the signal on the right that we call the actionable signal. And that's a signal telling you what's happening in the scene. Okay, you don't, you see people walking around, you see people running, and so that's kind of the power of this approach. You're doing it with minimal resources here. Okay, you don't need a supercomputer, you don't need a lot of battery, you don't need a lot of bandwidth. On the left side, it played too fast for you guys, but that was we demonstrated that single chip, the ability to catch, gunshots. Okay, because we can run our chip in the megahertz now. We don't have to worry about the amount of data because it doesn't send a lot of data out. It only sends the data that's relevant. In fact, we did a cool demo last week where we measured how much rainfall. We can use that was the top right video here. Those are actually water drops. And we can actually use our chip to figure out how much rain there is. There is a customer in Southeast Asia apparently interested in that technology, in that capability, because they get a lot of floods. On the bottom here is, if you guys dislike tolling as much as I do, every time you're driving on a toll road, there are sensors trying to figure out, how many axles you have to charge you properly. So we have our sensor mounted now on a toll station in Illinois, and what you're looking at, on the bottom right corner, that's the signal that the customer needs. That pulse that shows that an axle is actually on the road. All these examples I showed you really are done with that single chip. So it allows you to do high-speed imaging. It allows you to do anonymous smart imaging, like the example I showed you of monitoring people at the park. We can completely protect the person's identity and still know that it's a person, that it's a woman, that she was walking a dog, and all of that. So that's kind of, in a nutshell, the potential for this technology, and you can take it in very different directions, as you can see here. And I hope, I didn't go too fast or too slow. I always like to end with our team. That's the best part of this venture. We have a great team, and we're definitely having a lot of fun working together. And I'm happy to take your questions and comments.
Hey, thank you. That was very interesting, and you did